Inmendham. You mustn't confuse criticism of your own theories and your own methodologies with the endorsement of the current paradigm in physics. You mustn't confuse criticism of yourself and your theories with endorsement of the excessive use of metaphor and dumbing down of physics, even at graduate level. I think the truth comes to graduates when they do undergraduate courses or graduate courses, when they do the masters and they do the PhD. The trouble is they learn some philosophical truths in their specific field, and they may or may not apply widely. The theoretical physicist may gain these philosophical insights that are troubling and plaguing modern physics, but he also may not. It is a philosophical problem that physics is meeting and running into, and there are those who say they don't care because by what a model is, it's a good model, it does a job. I don't care for trying to philosophically ask whether it is true or whether it could possibly true. Then there are those who try to act philosophically inclined but are selling it you as physics rather than a philosophical engagement. And they speak heavily in metaphor, which is a big problem with your physics itself. Too often you are putting forward the obvious nature of your assertions without clearly detailing where that principle has been outlined, not in its entirety. Too often you say things like, well, you can kind of see. Too often you say, in a sense it does this, without referring to the literal claim of what it actually is doing. No sense about it. Ultimate physics, ultimate philosophy is devoid of those ambiguous terms, in my opinion. You say, in your most recent video, you thought it not a good explanation, but in fact it was a good analogy and a good metaphor. This idea of kind of the literal matter doesn't get moved from there to there, but by way of some magical mechanism, the image and the properties are transferred from there to there. Nowhere is that process detailed. It's not detailed because nowhere have you detailed how it is possible to arrive at a consistent body in the first place, from one frame of update to the next. You've shown one example about, and you cite this as this gets you out of it, but you've not explained how it gets you out of it. The idea of two polarities, two properties. You show two cases with perpendicular reflections, but what about all the other angles? They're not perpendicular is one criticism. It's no great bearing actually, but it needs saying. You keep referring to this as these are the only two cases, but there's an infinite amount of cases where the angle of incident equals the angle of reflection. But the net result is no trajectories are changed of actual matter. Polarization might be, but what actually constitutes matter within your theory, a trajectory, an ultimate destination of the content, doesn't change. It can't be interfered with. And so it's not entirely clear how, statistically speaking, because it's a statistical problem for you to get to contain a conglomerate of bodies. The statistical likelihood is that any collection of quanta in your theory will disseminate amongst the amorphous, structureless whole. There will be statistical likelihoods of periods of clusters, but will then dissipate. You actually have to prove that there's a statistical likelihood in your schema of there being a cluster here of said properties, and then a cluster here of said properties, of same said properties, and the moving of these things. You've not demonstrated that at all. And it's difficult. I would cite the Nima video when he talks on philosophy of science, where we concedes this all might be bogus, non-ultimate truth, but the way science works is this radical conservatism, and by looking to utility of theories and throwing out the whole basket of assumptions about waves and fields and all the progress that has been done about models that work and have a utility to science as that endeavour of making predictions. It's just so incredibly hard. In fact, he says every time you try to make a fundamental change to it, it almost is invariably so easy to instantly dismiss it. So people don't go so radically against the stream of mainstream science because it's so hard. And I guess ultimately the hope is, by the mathematical insights from where we're at, studying string theory and quantum mechanics and such, maybe it will come full circle through some productive chain of reasoning, and it may well reveal all those silly assumptions we made at the beginning. Ultimately it must, if it's to be correct in some sense. But until those future days comes, pretty much most of science understands that they're building a model, and it's at the extremes, it's hardly accepted wisdom. You know, not everybody is pursuing that model even. And the thing that is pushing them forward at the moment is abstract mathematical concepts and connections of relevance, which are difficult to ground in real philosophical terms. but the criticism is valid. That's what they're doing. They're not really informing the public of this journey. They're not, and half of them aren't even informed of the philosophical nature of what they're doing. They're just getting careers and books for themselves, and money, for sure.